And we're back. Okay, so this is the last section of 5.2. This is using the second fundamental theorem of calculus that we've used before. So just a reminder, I want to show you how it works. If you're going between a number and x, you end up with the same answer as what is here. I'm going to show you how it works though. So as a reminder, if you wanted to integrate this, you could do 1/2 between 3 and x of 1 over t dt. And then the integral of that is literally just 1/2 ln absolute value of t, different variable, between 3 and x, right? Plug in the x, so we get 1/2 ln of x minus 1/2 ln of 3. And then this is literally saying now find the derivative of that. So this is like f of x. So then if I found f prime of x, the derivative of this would end up being 1/2 times the derivative of ln of anything is 1 over that something times the derivative of that something, but that's just 1. And then this is a number, right? So that's like minus 0. So you end up with, by the way, this is just f prime, not double prime, 1 over 2x. Hence why it ends up being the same thing, but with an x thrown in there, which is cool. It's a little different when you have, so technically you guys can now, remember, as long as you're going from a number to x, you can jump straight to that. You don't even need to show the work. But when it changes a little bit, that's where you got to be careful. So we actually want to integrate this one. So just a reminder, you're integrating here, but then they want you to find the derivative of that because they're saying f of x is the integral, and then they want you to find the derivative. So what happens is we take the integral of cotangent of t dt. Now you guys know the integral of that. If you look back at your notes from last class, the integral of cotangent of u is ln absolute value sine of u plus c. So we're just changing the variable to t instead. So this turns out to be ln absolute value sine of t, and it's between 3 and 4x cubed. So then you plug those in, right? So ln absolute value sine of 4x cubed minus ln sine absolute value of 3. So again, now you just take the derivative of those things because this is really like f of x, and now we want f prime of x. So if I take the derivative of this, you have to be careful because this involves a little bit of chain rule. The nice thing about the tail end of it is it's just a number. So imagine this, if you plugged it into your graphing calculator, you get a value back. So if you take the derivative of it, you get 0. So we only really need to find the derivative of this first part, okay? So if I find the derivative of ln of anything, it's 1 over that something. But then we have to multiply by the derivative of what's underneath. So in this case, you have to be careful and multiply by the derivative of sine of 4x cubed. Now that in itself involves the chain rule, so just be careful. The derivative of sine of anything is cosine of that something, and then you have to multiply by the derivative of what's inside again, so 12x squared. So I actually like to rewrite it because we have a cosine over a sine here. That's really like, excuse me, because this is on the numerator. That's really like cosine over sine is really cotangent, right? I'm going to throw the 12x squared in front, and that becomes cotangent of 4x cubed. And that works as long as you have the same thing inside both. Okay, so this would be your final answer, which is a little bit different than what you had originally. All right, these ones you're going to find a little easier because it's asking you to find the area of the region. Just a reminder that that literally just means find the integral of x over x squared plus 1. Now, with that region, they're saying between 1 and 3. That's the important part because that tells you what you're evaluating between. So try this one out on your own, see if you can get it. Pause the video for me and your answer will be there. All right, hopefully you recognize that this involved some U substitution. If you're having trouble seeing that, just a reminder that if you have anything else besides x in the denominator, you're gonna have to do something with U. So that means we are integrating really 1 to 3 of 1 over U du, but remember there's a 2 here but not here, so we have to factor out that 1/2, okay? So now you integrate, so you get 1/2. A lot of people will forget to actually integrate it at this point, so just be careful. So you have to do ln of U, absolute value between 1 and 3, okay, because that's the integral. Now I can substitute U back in, so I get 1/2 ln absolute value of x squared plus 1 between 1 and 3, substitute the 3 and the 1 and subtract. Okay, so 1/2 ln of 3 squared plus 1 is going to be 10 minus 1/2 ln of 1 squared plus 1 is 2. Okay, the absolute value of 10 and 2 are both positive anyway, so you can just plug those into your graphing calculator. You don't even need the absolute value anymore, which is super duper. So you end up getting approximately 0.805 for that. All right. These are our last type of problems, the average value problems, but before we get into that, I'm going to have you try this one for me. Very similar to the last question, you are going to have to use a little U substitution. My hint to you for this, though, is split the integral. So you're going to integrate 2x and subtract the integral of tangent of 0.3x separately. Just a reminder that because this is a little more challenging, 3/10 is the same thing as 0.3. So use that in your value as well. Okay, so just see if you can figure this one out on your own. All right, folks, so hopefully you got through that okay. If you got 11.77, then you are good to go. Hopefully you got that. One thing to point out, and you can just kind of look through my work if you struggled with that at all. When you get to this step, where you do the absolute value of cosine of 0.3 times 4, if you plug that into your graphing calculator, it turns out to be a positive, so you don't even need the absolute value symbols. My suggestion is make sure you check whether your answer from the inside is positive or negative, because you don't really need the absolute value symbols if it's going to be positive anyway, because it's positive. So just check that out. If you had trouble with this part where you did U substitution, you don't really need U substitution if you can recognize that you end up with 0.3 on the outside. But if you had trouble from here to here, the integral of tangent of U is ln times cosine of U, so I plugged the U back in immediately. To cancel out the fact that you get 3/10 for du, you have to multiply by 10/3 because that gives you back to 1. And then from here, you can just plug this whole thing into your calc at once. So hopefully you're okay with that. Just a reminder for the average value formula, because some of us probably will forget, which is okay. It's been a while. But it's 1 over b minus a times the integral from a to b of f of x dx. So they give us our a and b. So what they really want you to do is just do 1 over pi over 3 minus pi over 4. Integral from, again, pi over 3 to pi over 4. I'm sorry, lowest on the bottom. Pi over 4 to pi over 3. And then our f of x is cotangent of x dx. So you hopefully are good to go with finding the integral of that. You can plug this part into your calculator. It doesn't come out to be nice numbers, so just make sure to use the rounded answer on paper, but then use the answer from your calculator. So you're doing 3.82 times the integral of cotangent of x, which is ln absolute value of sine of x. And then you're integrating that you did integrate that between pi over 4 and pi over 3. The nice thing is that the sine of pi over 4 and the sine of pi over 3 are both in quadrant 1. So the absolute value, again, doesn't really matter here because they're all going to be positive answers. So you can just do 2.82 ln of the sine of pi over 3 minus ln sine of pi over 4. And you can do that all in your graphing calculator. And then multiply your answer by 3.82 at the end. So you get 3.82 times, you get about 0.2 for this whole answer. So it comes out to approximately 0.77. Just to verify that you're plugging in correctly, I want you to try that as well. But the next question you're going to try on your own. It's a little bit more complicated because the integral involved requires some division. So just be careful. You want to distribute the x squared through. So that'll be my one little hint here, moving on to average value. When you integrate this function, I would simplify it first, so turn it into 4x plus 1 over x squared, and then distribute the x squared before you integrate. So you're going to integrate things separately. Just a reminder that you have to still do the 1 over b minus a and evaluate between 2 and 4. So try this one out, see if you get the same answer as me. Hopefully you do. All right, guys, hopefully you got about 1.886. If you didn't, just be careful of a few things. So one thing to notice is when you separate the integrals and you put the 1/2 in front, you end up with 4 over x plus 4 over x squared. Now, this has an integral of 4 ln of x, right? And hopefully some of us are just in that pattern of knowing what that is without having to factor out the 4. But this is the same thing as 4x to the negative 2. So when you integrate, you don't have to use an ln for that part. It's literally just 4x to the negative 1 over negative 1. So if you didn't get that, just notice this turns into subtraction because of that. I just divided by negative 1 there. So when you plug in, you have to plug in the 4 for both parts, okay, and then subtract what you plug in the 2 with, so what you get after you plug in 2. So just be careful of that. All right, nice job on that. If you have questions, please feel free to email me or join my office hours today, because today is the 3rd day. Yes, so I would have your class. No, that's tomorrow. I lied. Sorry, doing these ahead of time. Anyway, enjoy your day. Check in tomorrow if you need me to answer any questions. And we're reviewing tomorrow a little bit more on Monday. And then on Tuesday, we have our quiz. So talk to you soon. Enjoy your weekend if I don't talk to you.